Hello students. So in this class we'll learn about rate law expression. So for a reaction, this is a coefficient, okay, A plus BB gives CC plus DD. The rate is directly proportional to concentration of the reactant to the power X and Y. Okay. If you release this proportionality constant, then rate is equals to K is a rate constant, A to the power X, B to the power Y. Now this is known as rate law expression. So the definition, so rate can be written as is the differential rate is a dr by dt. Differential, this is the differential rate equation. So it's equal to K, A to the power X and B to the power Y. Now rate law expression, okay, so this is the rate law expression. So the statement of the rate law expression is a rate of a reaction. So it is a rate of a reaction in terms of molar concentration of the reactant with each term raised to some power, here is X and Y, which may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation. So that means it says that this X may be equal to this E, this Y may or may not be equal to this B. Okay, so this raised to, so is the concentration of the reactant raised to some power. Okay, so these two are the reactant, A and B are the reactant, raised to some power, this X and Y, which may or may not be equal to the stoichiometric coefficient A and B. Okay, X may be equals to A or may not be, Y may be equals to B or may not be, right? The next topic is the order of the reaction. So what is order of the reaction? The letter is small letter n. So this is the rate law expression. So order of the reaction is the sum of the power of the reactant in the rate expression law. So that means n equals to x plus y, okay, in this case. So what is order of the reaction? Order of a reaction is the sum of the powers of the concentration of the reactant in the rate law expression. So n equals to x plus y. Now we have to remember that order can be 0, order can be negative, order can be fractional. Okay, so variety of values can be expected for the order of a reaction. Another important term we have to learn is the unit of the rate constant, right? So this is the rate constant and you have to find the unit of the rate constant because it changes with the order of the reaction. So for example, if I write rate is equals to K and with suppose reactant to the power n, and now n is the order of the reaction, right? Now we can say that what is the unit of the rate constant. Now what is the unit of the rate? Rate means concentration by time, so it's a mole per liter by second. Second is the standard unit, right? And K we have to calculate, and this is the concentration of the reactant. Now concentration is always mole per liter, right? Per liter to the power n. Now only K equals to, what will happen is mole per liter per second, and this goes to the denominator, so it's a mole per liter to the power n. Now if I bring up here, so it's a mole per liter per second. Now it comes as a, okay, just mole per liter, it's a minus n. Okay, so nothing means we have to, if base is same, power should be added, so it's a mole per liter, mole per liter to the power 1 minus n per second. So with the help of this equation we have to calculate the unit of the rate constant. For example, number 1, zero order reaction. So that means n equals to 0, right? So we have to substitute the value here 0. So K equals to mole per liter, mole per liter 1 minus 0 per second. So this gives it's a mole per liter per second. So this is the unit of rate constant for zero order reaction. So it's a mole per liter per second. Similarly, for first order reaction n equals to 1, right? So you have to substitute the value here, n equals to 1. So this gives K equals to mole per liter 1 minus 1 per second. So 1 minus 1 is 0. So any number to the power 0 means 1. So everything becomes 1. So equals to simply per second, right? So number 3 for second order reaction. Here n equals to 2, right? Right. So I have already done here for second order reaction n equals to 2. So we just substitute the here n equals to 2, here n equals to 2. Okay, so 1 minus 2 is minus 1. So minus 1 you just multiply inside the bracket. So it's a minus 1. Now this minus positive. So unit of the rate constant K. So this is basically unit. Okay, unit of rate constant K for second order reaction is mole per mole liter per second. Next important topic we have to discuss is the molecularity of a reaction. So molecularity, according to the definition, it says that it is the number of the reacting species taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. So number of reacting species that must collide simultaneously. So we can think of unimolecular unimolecular reaction, right? Unimolecular reaction means only one reactant, it breaks to give B plus C. Okay, so unimolecular reaction normally we found in as a decomposition reaction, because only one molecule is there. Under the application of heat, normally what happens is it decomposes to give B and C. Okay, so only one molecule is involved, so it is basically unimolecular reaction. So there are also bimolecular reactions, in which two molecules are involved, right? Suppose bimolecular reaction A plus B, so it may gives C plus D or E, whatever. So two molecules are involved. So it says that the two molecules must collide simultaneously to bring about a reaction. But further it also says that the collision must have sufficient energy. Okay, so sufficiently energy ले collide हुनु पर्यो तब मात्रै reaction हुन्छ. अझै बादमा गएर भने चाहिँ proper orientation पनि चाहिन्छ, okay, to occur a particular reaction. But if two molecules are involved, then we can say it's a bimolecular. And number third one is trimolecular reaction. Now trimolecular means A plus B plus C, okay, gives whatever D plus E, whatever. So there may be many things. So we are just interested in the reactant. But the condition is they must collide simultaneously, okay, with sufficient energy, because the colliding with insufficient energy doesn't form the product. So now the chances is very less to collide a three molecule simultaneously at the same time. That means with sufficient energy, okay, and in some cases proper orientation is also required. So it's a bit rare, right? So and the reactions having more than molecularity 3 is very rare now, because the 4 molecules or 5 molecules colliding simultaneously with sufficient energy is not possible, right? So we do not see normally the reactions having molecularity 3 or 4 or 5. Okay, so we normally see unimolecular and bimolecular reactions. And remember, the molecularity cannot be 0. Later on there is a comparison between the order of a reaction and the molecularity, right? So we have already stated that order can be negative, order can be 0, order can be in fraction, right? But molecularity cannot be 0, because there has to be a molecule to undergo a reaction. So it cannot be fraction. So 1.5 molecule hundaina hai. So either 1 molecule or 2 molecule or 3 molecule in rare cases. So molecularity is a particular number. It could be 1, 2, 3, right? But more than 3 is very rare. So we'll just rule out the possibility. So molecularity 0 is not possible, and the negative is also not possible. We'll see this question here. It says that sorry, for a reaction A plus B, okay, gives the product, and the rate law is given by this: R equals to K A to the power half B to the power 2. Now what is the order of reaction? Now we know the order means we have to sum the powers of the reactant in a rate law expression. So it's x plus y, so x plus y, so x is half 2, so it gives 2.5. Simple. Next is number 4.4. It says that the conversion of the molecule X to Y follows a second order reaction. If the concentration of X is increased by 3 times, how will it be affected the rate of a formation of a Y? So we'll solve this one. So according to the question, right, so X is converting into Y. X is the reactant, Y is the product. Now for this equation, the rate law expression will be R equals to K X to the power 2, because it says that it follows a second order kinetics, right? So order, simple, one reactant is there, so obviously it has to be 2, because some of the powers of the reactant, only one reactant is there, so simply 2. So N equals to 2. So this is the order of a reaction. Now the question says that what will be the if the concentration of X is increased 3 times, how it affects the rate of a formation of Y. Okay, so rate, since okay, so if the concentration of X is increased by 3 times, that means R equals to K. Here it is a 3x, so concentration has been increased by 3 times. That means we will just take out 3 is a 9, so it is a 9K 3x. So sorry, 3 has already come out, so it's good. Okay, so R is equals to, again I'm just writing it to be more clear, right? So just compare this factor. Initially the rate is, so this is equation 1, this is equation 2. You're comparing the equation 1 and equation 2. So equation 1 is the initial, so it says the rate is equal to K X to the power 2. Here rate is 9 into K X to the power 2. So this factor, so this factor has been raised by 9 times. So we have to say that the rate has been increased by 9 times with the increase in concentration of the reactant by 3 times. Therefore we can write the rate of a reaction is increased by 9 times. Thank you.